In this TikZ diagram, we will simulate an electron emission system with labeled components, electrical circuits, wave-like emission, and direction arrows. This is perfect for physics, electronics, or engineering reports. First of all, document setup, we began by choosing the report class which is suitable for structured documents like technical reports or thesis. Here, the geometry package customizes our page dimensions. We have extended the page to 11.75 inches wide and 8.25 inches tall. Very small left and right margins. Only 5 millimeter give us almost full width space for a wide diagram, while keeping some top and bottom padding for neatness. We load the TikZ package, which is the head of LaTeX graphics. TikZ let us creating diagram using code like CAD for LaTeX. Now we enter the document and start the TikZ drawing environment. Everything from here onward will be part of our diagram. Draw a outer frame. We begin by drawing a large pink background. The color is soft pink with 20% intensity. It's shaped as a rectangle from the coordinates 0, 0 to 14.3 on top and down is minus 3 on the bottom. We also apply rounded corners with the 5-point radius to make the edges smooth. Then we outline our same rectangle with the thick, deep pink border. Using line width is 5 point for the clear visual emphasizes. Brown shape and blue beam frame. This is a polygon filled with brown at 60% strength. It starts from the right top 13.7, 1.3 and creates a slope going to down 10, minus 1 and then back up diagonally. This shape likely represents a part of the beam exact system. This is a rectangular blue outline on the far right. It might be a magnetic deflector frame or screen region. Again, it's it's thick colored blue at 60% strength and has slightly rounded corners. Cathode ray tube assembly. This rectangle filled in light black, just 10% darkness, is is likely the body of the electron source, like the vacuum tube or housing for the cathode. This uses a Bezier curve to make a curved side of the tube. It starts at the top and bends inward, creating a cylindrical field. We now add an ellipse on the right side of this tube to simulate a 3D cylindrical cap. Inside the big ellipse, we add a smaller one, maybe showing the beam aperture. Power connections. A horizontal wire extends from inside the tube to the left margin, representing the heating voltage circuit. We draw a wire with 90-degree bends that ends at the top of the tube. Another bent wire connects the right side to the device to top circuit line like a return path. We mark the connection point with a bold black dot. This circle with a plus sign representing a positive terminal. Voltage supply and symbol. On the left, we simulate an AC power supply using the approximable levels likely has a spanning heating voltage, and UH define this as voltage source for heating the cathode. A line connects it into the system. Electron emission spring. This this turning the line draws a compressed spring or spiral wave using parametric plotting. The x varies sinusoidally and the amplitude gets smaller as it goes downward. The y-axis slowly descends, simulating a flowing electron wave. The wave tapers off into a zigzag like a bunch of electrons converging and being pulled forward. Labeling each component, we draw a line pointing to the heated cathode and label it gluth, glo, glucose code. And another line points to the Wellnut cylinder which controls the focus of the electron beam. Our third line goes to the cooling or cooling unit at the far end. Violet electrons bullets. All these violet rods represent individual electrons traveling through the beam path. You can animate them in your video for more visual activity. Also, violet electrons bullets, green arrows, and beam direction. These final green arrows show the path of the beam being directed downward, possibly in onto a screen or directed and drawing. We end the ticket picture and close the LaTeX document that completes our technical drawing.